So let me also be clear as I discuss these, what I expect in terms of your work and justification for this. Since this is calculator active, right? Show me a picture of the graph. Well, actually, this is number one. So let's look at number one. Show me a picture of the graph, include that. And just state this maximum. All you have to do is state it because there's no supporting work for that. And then for C and D, all I would expect to see is this. So it's not necessarily a huge amount of writing for this. But do, at minimum, show what you're putting into the calculator and what you're getting out. So basically the standard on any kind of calculator active work in terms of showing justification, show what you put into the calculator and show what came out. That's basically how it goes. All right, so let's go ahead and flip the page and start number 5. So on number 5 in this lovely worksheet that you're going to do, number 5. So I have a chemical plant that's producing industrial hydrogen, stores it in a tank. So the plant produces hydrogen at a rate modeled by capital R of T. So capital R of T equals 127 times 1 minus e to the power of negative 0.1 t. Oh, I get some little extra mark there. Okay, that's liters per hour. Okay, now after 5 hours, a valve is opened, and now the plant is still producing hydrogen at the same rate, but now the tank is being drained at a rate of R of T. All right, so little r of T. And this is pretty typical setup for these kind of problems. And by the way, the AP exam loves to set up problems like this, where certain processes are operating at certain times. And what they're doing is they're really creating a piecewise function for R. All right, that's also liters per hour. All right, so here's what's really going on. Let's start by creating a function. And I think this would be sort of a good habit for all of these types of problems. That's interesting. I talk to myself while I'm doing these problems. I do the same thing in class. Anyway, in these problems in general, they give you a function for a rate, but they don't give you a function for the total of whatever quantity you're really tracking. We need to do that. We need to create a function h of t that gives the hydrogen, the amount of hydrogen in the tank. Because both of these are rates. So this amount of hydrogen tank is going to be the number of liters you have. So a lot of times you have to create an auxiliary function that represents the amount of whatever you're given the rate of. All right. So now what happens here is h prime of t is now a piecewise function because this is only for t greater than or equal to 5. Right. So h prime of t is equal to, all right, the plant produces hydrogen, so that means we're getting more hydrogen. You have to look at the difference between words like produces and releases, because this rate is going to be positive, but this rate is depletion, so it's going to be negative. All right, so h prime of t, first of all, in the first 5 hours of operation, all there is the production of hydrogen. We're not distributing any hydrogen yet, so that's what h prime of t is for 0 less than or equal to t less than or equal to 5. But then once t is more than 5, the h prime is now going to be capital R of t, the rate at which we're producing hydrogen, minus small r of t, the rate at which we're dispersing hydrogen. So that is to say 127 times 1, I guess I have to rewrite that. 127 times 1 minus e to the negative 0.1 t minus 7 e to the negative 0.5 t plus 3. That is for t greater than or equal to 5. And I guess we don't really have anything limiting that. So for all t greater than or equal to 5. All right, so it's a piecewise function. We have t less than 5, we just have this function. T greater than 5, we have both of these functions. So part A asks, how much hydrogen is in the tank at t equals 5? All right, so what they're asking us for is h of 5, and that has to be equal to h of some prior known value. Now, what I've done in this problem, and I wrote all this stuff, unfortunately, I have no one to blame but myself, and I left something out of here. I didn't say what the amount of hydrogen was at any particular time. So we always need that. For example, at t equals 0, there's a base of 13 inches of snow. Or at t equals 3, there are 1,300 liters of oxygen. All right, we need a particular time, and I didn't put that in here. So in number 5, what we're going to do is assume that h of 0 equals 0. In other words, the tank is empty when we first started producing industrial hydrogen. So that's not optimal. I could have written the problem better by stating that the tank starts empty. It doesn't say that. So but we have to assume it because what else are we going to do? All right. But so the problem is defective. We're going to fix it by saying the tank starts empty. All right. So then we can say h of 5 equals h of 0. Now I'm starting with h of 5 partly because that's what part A is, how much is in the tank at t equals 5. But by the way, if they didn't ask me part A, if they just asked me part B, I would have to start with h of 5 because that's where the rate changes. Right? So I would have to split it up into how much material is there at t equals 5, and then how much is there at t equals more than 5. All right, so h of 5 equals h of 0 plus the integral from 0 to h of our r of t, this rate, right? R of t dt. And I really only have to write that. And let's see what that is. So our h of 0, we arbitrarily decided was 0. What is this? Is that a 5? That's supposed to be a 5, right? 0 to 5 because 0 to 5. All right, now I've also put under my y functions, my y2 is that capital R. So that means that I can do, I'll put 0 plus even though it doesn't do anything. But that's, that starting value plus math 9 for the integral. We're doing 0 to 5. And I have to remember that my R function was in y2. So variables, y variables, function, y2. And then I just put dx, enter. And now I know there's 135.294. Well, I mean, technically I have to add the 0 first. All right, equals 135.294 liters of hydrogen at time 5. All right, so I could say that there's 135.294 liters at time 5. But by the way, my saying h of 5 equals 135.294 liters, having said that h of t is the hydrogen in the tank, that answers the question. That answers part A of the question. All right, so now for part B, I have a different rate. All right, so for part B, I'm looking for h of 10. So what I can do is use this h of 5 as my starting value. I'm going to say it's equal to h of 5 plus the integral from 5 to 10 of h prime of t in this interval is capital R minus small r, capital R of t minus small r of t dt. So now I can just put that in my calculator. I know the h of 5 is 135.294 plus, and then I can go into my calculator. Well, let's put that I could just use the same number, right? So I could just go plus, right? Because that's going to add to that same number, plus math 9 for the integral. We're going 5 to 10 now. And so, right, I want to emphasize that the capital R is hydrogen being produced, the small r is hydrogen being consumed. That's why we're subtracting the small r. All right, so we're going to do variables, y variables, function, y2. And then I put the other function into y3 already. See, it's right there. Hopefully I put it in correctly. If I didn't put it in correctly, then I'm going to be wrong. Okay, y of 2, and then minus vars, y vars, function, y3, and it is dx. All right, and I just hit enter, and I get a syntax error. By the way, a great thing to use, if you guys haven't seen this yet, use the goto. Don't just use the quit, use the goto, because it'll tell me where the error is. Usually it's like a missing parenthesis. It doesn't like that I tried to put that number in there when it wasn't there. So what we're going to do is we're going to go back here, and let's see. What we'll do is we'll go here. We'll go second insert, and then I hope this will work. I'll go up here and press enter. Yes, not bad, right? So then I pulled that whole number down in there, and then I hit enter. And now, so use the goto and not just the Yeah, okay. So now there's 196 liters in the tank. because I put the number plus the integral, I can't really put 135,294 plus something. So let's just say plus the integral from 5 to 10 of r of t minus r of t dt. But I could skip this step and just jump to my answer of 196.019 liters. I was a little bit surprised that we still have more hydrogen, even though we're distributing it. But apparently we're producing it faster than we're distributing it, so we still have a surplus of hydrogen. And that makes me happy because we can fill balloons and stuff, or power alternative energy vehicles. All right, so that is this, which is homework. And I think there's going to be more.